Okay, now so in this lecture we will study what is the Cholesky's method. I told you the basic concept of Cholesky's method. If you want to write this, the main four steps are just as before. But if you want to apply the Cholesky's method completely in terms of lower triangular matrix, then without disturbing its pattern, you write L into, and instead of you write L transpose. And if you want to solve it with completely entirely upper triangular matrix, then without changing its order, you write instead of L U transpose. Then you can find out. And there are two conditions, two prerequisite condition to apply this method. First one is that your matrix A should be symmetric. Symmetric means, as you know, symmetric means A transpose is equal to A. So if you take the transpose, then it should be equal to its original matrix. And second one is it should be a positive definite matrix. So positive definiteness is if you have any unknown value or specific value or any journal value, column vector, so you take its transpose. Like if you have x1, x2, x3, so column vector, so you take its transpose and you multiply it with the coefficient matrix, and then you multiply its product with the original column vector. And if it is a positive quantity, then it means that it is a positive definite matrix. So x1 x may be a column vector, x1, x2, x3 it is a journal vector, or if it is a, you can take the specific values like 2, 3, 5, and the product would be a constant. And if you take the values as it is, then it will be the equation kind of or inequality kind of thing. So you can judge it that whether it is a positive definite or not. Okay, so we start applying these two conditions in the example, and then we start solving it afterwards. So example number 1 is for solved by Cholesky's method, and that is 2x1 minus x2 is equal to 3, and minus x1 plus 2x2 minus x3 is equal to minus 3. And the third one is minus x2 plus x3 is equal to 2. Okay, so first condition is you check it's symmetric or not. So you can also check by symmetry. It means that A12 element is equal to A21, A13 should be equal to A31, elements should be same, and A23 is equal to A32, and so on. So these are for 3 cross 3. So you can match it. If I write it by this coefficient matrix, then you can see that it's symmetric. So 2, minus 1, 0, minus 1, 2, minus 1, 0, minus 1, and 1. Yes, A12 is equal to A21, A13 is equal to A31, and A23 is equal to A32. So yes, it is symmetric. For the positive definite, so first condition is satisfied, so second condition is positive definite. And if I take it's this vector x1, x2, x3, and transpose means rows are changed into columns and columns are changed into rows, so it's transpose will be x1, x2, and x3 in the form of, it becomes a row vector, and I multiply it with this matrix, that is 2, minus 1, 0, minus 1, 2, minus 1, 0, minus 1, and minus 1. And afterwards we will multiply with its original vector, x transpose A into x should be greater than 0. So if you know that the product of order of first vector, like if you have this product 1 into 3 through first row 3 columns, and also this has the other coefficient matrix as 3 cross 3, then the resulting order will be 1 cross first one and the last one, so 1 cross 3. So just multiply it, and then you will get its first 1 row and 3 columns, just like this x1, x2, x3. So we start applying it. So first row and first column is the first element, resulting first element. So 2x1 minus x2 plus x3. That is first element of this row vector, and then first row, second row and second column, that means minus x1 plus 2x2 minus x3, and then also third column, that makes it minus x2 plus x3, and then I write it x, that x vector is x1, x2 and x3. Okay, so this is basically 1 cross 3 order, and this is 3 cross 1 order. So resulting will be 1 cross 1 order. So that is a constant. Okay. So this element with x1, so that makes it 2x1 squared minus x1 into x2 plus x1 into x3, and also plus if I multiply this with x2, then it will be minus x1 into x2, okay, plus 2x square minus x3 square. Okay, so third will be minus x2 into x1, so minus x1 this one plus x1 x3, and also minus x2 square plus x2 x3 and plus x3 square. Okay, so I solve it and I take the values, and you can see that this value becomes 2x, that makes it 2x2 square minus x2 square, so that makes it plus x2 square and x2 and x3. There is another x2 and x3. Okay, so I select this. It cannot be solved further, so x2 and x3 plus x2 x3, x1 x3 and x1 x3, so that makes it plus 2 x1 x3, this one and this one, and we are left with x1 x2, and this one is minus 2 x1 x2. I apply any specific vector, like x1 is 1, x2 is 5 and x3 is 7. So if I apply 1 square is, that makes it square, that is if I any random value. Okay, so this is fine, 1 minus 5 and minus 7. Okay, in any random value, so 1 square is 1, x2 square is plus 25, and x2 into x3 minus 5 into, that is plus 35, plus 2 into x1 into x3, so that is minus 7, and also minus 2 into x1 into x2, that makes it minus 5. So what will be the product? I think the most dominant terms are from the positive side, so that makes it positive, and we get 25 plus 35 is basically, I think it's 60. 5 plus 5, and then 60 plus 1, 61, 61 plus 10, 71 minus 14. So it is a positive matrix. We can see it. 11 minus, take any other value with the positive and negative combination to get its combination as positive number. So yes, it is a positive definite. Now we will start applying this Cholesky's method in the form of lower triangular matrix, and that is matrix A is 2 minus 1 0 minus 1 2 minus 1 0 minus 1 and 1, and that is equal to L11 is this, L22 is this, and L33 is this, L21, L31, L32, 0 0 0, multiply by take its transpose, and that is L11, L21, L31 and 0 L22, and that is L32, sorry, L32 and also 0 0 L33. Okay, So start comparing it. 2 means A11. So first row, first column, L11 square plus 0. So that makes it L11 is under root 2. Okay, so next one is what makes it L21 minus 1. So A21 first row, A12 first row and second column. So L11 into L21. So plus 0. So replace the value of L11. So that is L21 makes it this minus 1 by 2. And also, so we have basically 1 2 3 4 5 6, only 6 values for, and that means we are only concerned with the 6 equations to find out these unknowns. Okay, the third one is 0. So first row and third column. So 0 equals to first row third column means L11 into L31 plus 0. So that makes it L31 equals to 0. Okay, now 3 equations are left, and that is L21 into L11. L21 is find out, so I take it, I have to find L22. So 2 is equal to second row second column, so L21 square plus L22 square plus 0. So this will give a rise to the L22. So L21 is 2 plus minus 1 by it's basically minus 1 by under root 2 square plus L22 square. So 2 is equal to 1 by 2 plus L22 square, that is 2 minus 1 by 2, basically 3 by 2. So it is complete under root of 3 by 2. So that makes it, if I replace these values of L22, that makes it under root 2 by under root 3 by 2 by 3. So I would equal to it is 0, and that is 2 by 3 plus L33 square. So 1 minus 3 is 1 minus 2 by 3 is 3 minus 2, so that is 1 by 3. So L33 square is 1 by 3. So that makes it L33 equals to 1 by under root 3. So I replace these 6 values with these equations, and that is L11, L22. I would write it here. So L11 is 2, L21 is minus under root 1 by 2, L22 is under root 3 by 2, and L31 is 0, L32 is minus 2 by 3, and L33 is 1 by under root. We will start solving it with L y equals to b. So L here is 2 0 0 minus 1 by under root 2 under root 3 by 2 0 0 minus under root 2 by 3 and 1 by under root 3 into y is y1 y2 y3 and b is 3 minus 3 and 2. Now we start to find Ly equals to b. So under root 2 y1 equals to 3. So y1 equals to 3 by under root 2. And also second equation is minus 1 by under root 2 y1 plus under root 3 by 2 y2 is equal to minus 3. So that is I guess 3 by under root 2 plus 3 by 2 y2 minus 3. So minus 3 by 2 plus 3 by 2 y2 equals to minus 3. So minus 3 plus 3 by 2, that makes it minus 6 plus 3 by 2 and minus 3 by 2. Okay, so y2 is equal to if I cross multiply it with this, then it becomes under root 2 and then it becomes under root 3. So that makes it, if I cancel this, it becomes minus under root 3, and that becomes minus under root, under root 2, so that is minus 3 by 2. Okay, equation is minus under root 2 by 3 y2 plus 1 by under root 3 y3 is equal to 2. Minus 2 by 3 multiplied by minus 3 by 2, so that it is basically 1 plus 1 by 3 y2 equals y3 equals to 2. So it is positive 1 plus 1 by under root 3 y3 equals to 2. So 2 minus 1 is 1, y3 is 1, and if I cross multiply it, basically it is like this, and y3 is under root 2 minus 1 by under root 2. Basically I have to take this L transpose and 0, so 0 under root 3 by 2 and minus 2 by under root 3, 0, 0, 1 by under root 3 into x. X is x1, x2, x3 equals to y1 is 3 by under root 2. y2 is minus under root 3 by 2 and y3 is under root by backward substitution process, and that is 1 by under root 3 x3 is equal to under root 3. So x3 under root 3 into under root 3, that makes it 3. Okay, so next equation is under root 3 by 2 complete under root x2 minus 2 by under root 3 x3 is equal to minus under root 3 by 2. Okay, replace the value of x3 here. I am replacing it here, so that makes it under root 3 into 3, so that makes it under root 3, and that 2 into 3 means it's under root 6. Okay, so shift it to 3 divided by under root 2 plus under root 6. So if I take the LCM, then we get under root 3 plus 6 into 2 is 12. So if I take the factors out of this, 4 into 3, so 4 has under root 2 and 3 and under root 2. Yes, it's all 2 minus 1 is 1 and 2 minus 1 to under root 3 divided by under root 2. So that is under root 3 by 2 is equal to under root 3 by 2 x2. So x2 is 1. If I solve it, that cancels each other. Okay, x2 and x1. Now apply these values of x2 and x3 in this first equation. Under root 2 x1 minus 1 by under root 2 x2 plus 0 equals to 3 by under root 2. So I guess 1 by under root 2 is equal to 3 by under root. That's so simple. If I shift it towards other side, that makes it 3 plus 1 by under root 2. So that is 4 by under root 2. So if I divide it with this, x1 equals to 4 divided by under root 2 into under root 2. So that makes it 4 by 2. 2 into 2, that makes it simple 2. So x1 is 2. So solution set is x1, x2 and x3, and that is equal to 2, 1 and 3. So that is the answer.